My name is Naomi Shorman, and I want to talk to you today about predicting non-adherence in diabetic patients using data from wearable devices and health applications. So, what is the problem we face? Well, chronic disease management, such as diabetes, often involves continuous monitoring of patient metrics, and non-adherence to treatment or lifestyle recommendations significantly increases complication in this patient. So I propose a machine learning-based solution to predict non-adherence risk for diabetic patients using both wearables and application data. So why this is an attractive opportunity? First of all, the data is available. The wearables and mobile health app generate large volume of both structured and unstructured data, which provides a solid foundation for training and validation machine learning models. Prediction of non-adherence can trigger interventions such as reminders and personalized tips or alerts to healthcare providers. Well, these interventions are directly actionable and can lead to better health outcomes. And third, it is feasible with advances in cloud infrastructures and pre-trained models. This solution can be implemented at scale, ensuring technical feasibility. Okay, so our business objective is to develop a machine learning solution to predict the likelihood of a diabetic patient failing to adhere to their treatment plan, medication, diet, activity within the next 7 days. We need to ensure privacy and comply with HIPAA regulation, and we need to minimize false positive to avoid unnecessary interventions. So our key questions are: what data sources best reflect adherent behavior? How can predictions be integrated into existing health workflow? And what features contribute most to these predictions? So our outcome metrics are the reduction of non-adherence. We aim to a 20% drop in adherence-related complication and improvement in patient health. We need to lower the average HbA1c levels for diabetic patients. So our output metrics are precision, recall, and F1 source of machine learning model on test data, and engagement rate when intervention triggered by predictions. So our key factors for prediction include the glucose monitoring data, the wearable data, the app usage logs, and demographic and health history of these patients. So the solution involves training a time series machine learning model on wearable devices data and app usage patterns to predict adherence risks. Prediction will inform the care teams and trigger tailored patient interventions. So first, we need to collect historical data from wearables and from these applications and identify the patterns correlating with adherence and with non-adherence. We need to establish a benchmark, a baseline models. We need to train a simple model to establish this benchmark, and we need to do iterative refinements. We need to use a more advanced models and then features iteratively. And then we need to conduct a validation, an A/B testing, to measure the model's impact on patient outcomes, to gather feedback from healthcare providers and from patients. And then we need to test the real-world environment while monitoring a model performance. So our model selection of choice is long short-term memory network because it is ideal for sequential time series data, capturing trends in patients' behavior like glucose reading and app activity logs. We need to use features like glucose trends, physical activity, app usage logs, and demographics, while these features are readily available and show a direct link to adherence. We need our infrastructure to be cloud-based platform because it is scalable and compliant with healthcare care and data regulations. So what are the potential risks in production? So first of all, it is the difference between training data and the live data. We need to ensure real-time data pipelines are consistent with our historical data for sessions. Second of all, we need the patient behavior patterns. We understand that the patient behavior patterns may change over time. So we need to regularly retrain the model with recent data to adapt to these changes. We have a risk of exposing sensitive patient data, so we need to encrypt all data and implement robust access controls. And we need real-time predictions that may face delays, so affecting timely intervention. We need to optimize the model interface time and consider edge computing solutions for these wearable devices. So in conclusion, our machine learning solutions aim to address the critical issue of non-adherence in diabetes management by leveraging wearables and data app to predict and mitigate risks in real time. This approach not only empowers healthcare providers with actionable insights, but also enhances patients' outcomes, reduces complications, and drives significant savings in healthcare costs. By implementing this solution, we take a meaningful step towards transforming chronic disease management through the power of machine learning. The next steps involve refining this model, conducting pilot tests, and scaling the solution to create a lasting impact. Well, that's it. Thank you very much.